Hello everyone, I'm Shivani and welcome to Civil Series. This video is about the detailed explanation of Test Series 3 which is based on highway engineering. Up till now, if you haven't attempted the test, the link of the test is given in description comment section of this video and also the link is available in the community section. So let's start with the first question. In India, yellow and white color on milestone indicates. So for different kind of highway, different colors are given to milestone. So for national highways, the color is yellow and white. So here first option is correct. But for remaining highways, the colors are for state highway the color is green and white. For village road, the color is orange and white. For city or the main district road, the color is blue, black and white strips. Okay. So here for national highway, the color is yellow and white. The next question. Then question number 2. The total width of road is 10 meter and camber is 2%. Find the height of crown of road. Okay, so this is the diagram for the height of crown. So h is the height of crown and here the h is equals to w by 2n. W is the width of the road and n is the cross slope or the camber. Here the camber is given which is 2%. So 1 by n is equals to 2%. So 100 by 2 is equals to 50. So take 1 by n value or n value as 50. Then h is equals to 10 divided by 2 into 50. The height of crown is 0.1 meter here. So option number D is correct. The height of crown of road is 0.1 meter. Third question. What will be the ruling minimum radius for horizontal curve of national highway in plain terrain? Assume ruling design speed 127 km per hour, minimum design speed 80 km per hour, rate of superelevation is 0.05 and coefficient of friction is 0.05. So this is the formula to calculate the ruling minimum radius, which is E plus F is equals to V square divided by 127 R ruling. So this formula is in terms of kilometers per hour. So put the given values into this formula. After calculation we get the ruling radius as 1270 meters. So here option number C is correct. Then fourth question, what is the mechanical extra widening required for a two-lane pavement of width 7 meter on a horizontal curve of radius 250 meter if the longest wheelbase of a vehicle expected on the road is 5 meter with a design speed of 70 kilometers per hour? So to find out the mechanical extra widening, the formula is NL square divided by 2R. So the mechanical widening and psychological widening is, if we add the mechanical widening and psychological widening, then we get the extra widening here. In the question, the mechanical widening is equals to NL square divided by 2R. So N is given here, which is 2-lane pavement. So N is equals to 2. Then the length is 5 meter and radius is 250 meter. After putting the given values into this formula, which is NL square divided by 2R, then we get the mechanical widening as 0.1 meters. So here option number C is correct. The next question, question number 5. What nature of wrapping stresses are generated in a reinforced cement concrete pavement during a summer day? So during summer day, the wrapping stresses generated in the reinforced cement concrete pavements are, so first, in the bottom fiber, the tensile stresses are generated. Okay, and in the top fibers, the compression stresses are generated. So here the option number first is correct. Tensile in bottom fiber and compression in the top fiber. The next question. Then question number 6. For a hill road with ruling gradient of 6%, what will be the compensated gradient at a curve of radius 60 meter? So to find out the compensated curve, the formula is, there are two formulas. From that two formulas, whichever the value is lesser, we take that value and we subtract that value from the ruling gradient. Okay. So to find out the compensated gradient. So the gradient, first grade compensation is, so for grade compensation, the formula is 30 plus R divided by capital R. So first formula is this 30 plus R divided by capital R. After putting the given value, which is 60 meter, R is equals to 60 meter. So this 30 plus 60 divided by 60 is equals to 1.5%. The next grade compensation is 75 by R percent, which is equals to 1.25%. In the given two values or in the calculated two values, 1.25% is a lesser value. So take the grade compensation as the lesser value. Then subtract the grade compensation value from the ruling gradient, then we'll get the compensated gradient. So compensated gradient is here they want to calculate the compensated gradient. Okay, so compensated gradient is equals to ruling gradient minus grade compensation. Grade compensation formula is, first formula is 30 plus capital R divided by capital R. Second formula is 75 divided by capital R. Okay, from the two formulas, whichever the value is lesser, we take that value and subtract that value from the ruling gradient, then we'll get the compensated gradient, which is equals to 4.75%. So here option number third is correct, which is 4.75%. The next question, which one is not a road pattern? Which one is not a road pattern? So there are different kind of road patterns. So in the option number first, block pattern, yes, block pattern is the road pattern. Star and block pattern, hexagonal pattern, all the three are the road patterns. Okay, but the diamond pattern is not a road pattern. So here last option is correct, which is diamond pattern. There are different type of road patterns. In that, first one is rectangular, block pattern, then radial or star patterns. In the radial or star, first is block, second is circular, third is grid pattern, and last one is the hexagonal pattern. Okay, so these are the patterns for the road. The next question, a road sign indicates no parking. So for no parking is mandatory sign, required sign. So here the second option is correct. So no parking is considered under the mandatory sign. So these are the different cautionary, informatory, mandatory. These are the different types of road signs, and all the three signs have a different kind of colors for border and for background. So these are the color for the border and background, and these are the shapes for the different sign. So this is the important chart. The next question, on a right angle two lane road intersection with two-way traffic, the total number of potential conflict points are, okay, total number of potential conflict points are, in the question two lane road is given, okay, and two-way traffic is given. So total number of potential conflicts are, so for different type of roads, for different lane of road, for two-way traffic, for one-way traffic, for one-way and two-way traffic, for all the different kind of traffics, the potential conflict is different. So this is the chart for potential conflict. So in the first, number of lanes are given. If road A has 2, 2 and 4 lanes, if road B has a 2, 4 and 4 lanes. Here for the number of potential conflict, three conditions are there. In the first, both roads are two-way. Second, A is one-way, B is two-way, and last, both the roads are one-way. Okay, so this is the chart. In the question, two-lane road means road is two-lane and traffic is two-way. Okay, so two-lane road and traffic is two-way. So this is two-lane here, and traffic is two-way. So for this given particular question, the potential conflicts are 24. So last option is correct here. The next question. Then question number 10, the interface treatment provided to plug in the voids of porous surface and to bond loose particles in bituminous pavement is called as. So here the interface treatment used to plug the voids of porous surface and to bond the loose particles in a bituminous pavement is nothing but a prime coat. So here third option is correct, which is prime coat. Tack coat. Tack coat is the tack coat is provided for proper binding between two layers of binder coats, and that tack coat is thin coat. Then seal coat. Seal coat is also a thin surface treatment which is used to provide a waterproof surface and provide the skid resistant surface. So the next question is, then question number 11, the type of transition curve that is generally provided on heel road. So the type of transition curve for the heel road is spiral. So your last option is correct. And the second, the cubic parabola is provided for the railway. For the heel road, the transition curve is spiral, and for the railway, the transition curve is cubic parabola. So here the last option is correct, which is spiral. Then question number 12, for list scoring and hard ground, which type of foundation is used? So the first option is raft foundation. Raft foundation is used where if we calculate the area of foundation, that area of foundation is larger than the area of plot, then we use the raft foundation, or we use the raft foundation in the black cotton soil. The next is sprayed foundation. The sprayed foundation is used in the hard ground. The next, pile foundation. Pile foundation is used in that kind of soil which is not hard enough to resist the foundation. So there we use the pile foundation. But here in the question they ask about the list scoring and hard ground. So for hard ground we prefer the sprayed foundation. Here option number second is correct. The next question. Then question number 13. Which of the following pair is not correctly matched regarding type of road surface and IRC recommended value of camber in very heavy range place? In very heavy range place, there are two ranges, heavy rainfall and light rainfall. In the question, heavy rainfall range is given. So the first type of road or first type of road is with cement concrete and high type of bituminous surface. So first is cement concrete and high type of bituminous surface. The range is in between 1 in 50 and 1 in 60. 1 in 50 for the heavy rainfall, 1 in 60 for the light rainfall. So third is correct. Second is about the thin bituminous surface. So for thin bituminous surface, first range is 1 in 40 and second is 1 in 50. So for heavy rainfall, 1 in 40 is the correct range. But here the 1 in 65 is not correct. So in the question they ask about not correctly matched. So option number 4 is not correct here. Then we'll see the remaining option. Next option is waterbound macadam and gravel pavement. For waterbound macadam and gravel pavement, the range for heavy is 1 in 33 and for the low 1 in 40. So this first is also correct. Then last is earth surface, which is 1 in 25. This is also correct. 1 in 25 for heavy rainfall and 1 in 33 for light rainfall. So this is also correct. So here the option number 4th is correct, which is thin bituminous surface. The next question is, then question number 14, the maximum superelevation on heel roads should not exceed. So there are different kind of superelevations for different kind of road or different kind of plane conditions. So first condition is for plain and rolling terrain. So for plain and rolling terrain, the superelevation is 7%. For hilly roads, the superelevation is 10%. Last, for urban road, the superelevation is 4%. So here option number 4 is correct, which is 10%. 10% is the maximum superelevation for the hilly roads. Then next is, an engineering survey is proposed in a highway alignment project. The survey include following stages. So for engineering survey, there are 4 stages. In that, first one is map study, second is reconnaissance, third is preliminary survey, and last one is final location and detailed survey. So by arranging these 4 steps, third is first here. So this is first, reconnaissance is second, preliminary is third, and final location is fourth. So here option number 1 is correct as per the sequence. The next question. Question number 16. Remaining questions are one-liner questions. So in that, first one is widening of roads on hilly region is done. So widening of roads on hilly region is done on inner side. So option number second is correct here. Then next question. The instrument used for measuring the spot speed, that instrument is inoscope. So your option number C is correct. The next question, the rate of rise or fall of formation level of a road along its alignment is called as. So the rate of rise or fall of formation level of road along the alignment is gradient. Option number C is correct here. The next, temperature stresses in concrete pavement may cause the slab to crack. If pavement slab cools uniformly, then the crack will develop at the following location of slab. If the temperature stresses in the concrete pavement may causes the slab to crack. If pavement slab is cools uniformly, then that cracks is developed at the center of the slab. So your option number second is correct. Then the last question from this test series, which is, which one of the following method is used in the design of rigid pavement? So the design of rigid pavement, the method is Westergaard method. So here option number C is correct. So this is all about the test series 3, which is based on highway engineering, and thank you for watching.